Alrighty, so the next thing I'm going to go through is the steps that you need to take to prepare your Replicator 2 for printing. Now, the first thing I wanted to talk about was just practical tips about what I would call sort of PLA or filament hygiene. Now, the filament is the stuff that you're printing, and so of course it really matters that this comes through the printer without any contamination and also without any tangles. And so there's a couple of things that you can do to look after this stuff. There's some debate as to whether you know, PLA is apparently hydrophobic, which means that it doesn't absorb moisture compared to other plastics like nylon or ABS. Nevertheless, it will absorb some moisture from the air. So the thought is that it's more of a gradation. ABS is more prone to absorbing moisture than PLA, but PLA still can. If you live in a very dry climate, it's probably not an issue. I live in a climate which is dry part of the year and very humid for part of the year. So for me, it seemed like a good idea to just deal with it now rather than worrying about it later, seeing as I've got maybe 14 rolls of filament there, and I don't want them going bad on me and finding out later that I've ruined them. So what I do is I store the filament in these giant Ziploc bags in a container. Inside the bag we've got a little satchel of desiccant. You can put that in an oven with just the warm function on, so like the plate warming function, so it doesn't get too hot. For say 10 minutes, it'll dry them right out. And whenever you finish with a roll, just put it back into the bag. You know, evacuate a bit of the air, and that'll just keep it reasonably dry and keep the moisture out of it. As I said, I mean, it's not a huge problem, but I think it's better to keep it in something like this and know that it's fine than take a risk on ruining like rolls and rolls and rolls of the stuff. The other thing I did was I printed these little clips, and they're like a little flexible clip for like that you can print in PLA. A lot of the other ones on Thingiverse were really designed for ABS, and PLA and ABS are quite different in terms of their properties. So PLA is a lot stiffer. So anyway, I designed this little flexible clip, and it just clips onto the flange and holds the end of the filament in place so that it doesn't run around inside there and get tangled up. One of the problems you can have is that if the filament knots on itself, you can have a print failure simply because the filament won't feed properly. So having a set of clips is a good idea. Some reels like this one have a little hole on the end that you can feed the thing through to you know, when you finish printing, you can just feed the last bit through like this, and it'll just hold it in place. The problem is it's not always in the right spot, so you end up with like big bits hanging out the end, and then they can get crimped and all that sort of stuff. So I decided to make a set of clips that just do the same job, but they just go wherever you want them to. It's all good. Next, I'm going to talk a bit about measuring the filament. Now, all filament that I've got comes in different sizes, even though it's, you know, like even though it's 1.75 millimeters, the range of sizes is actually quite significant. So I've got some of my PLA is 1.69, some is around 1.75, and some of it's about 1.8 to 1.82. So what you'll need is a set of digital calipers. These are cheap ones I bought on eBay. I've got better ones in my shop, but these are fine for doing this. And what you want to do is you want to put the filament in the tip just there, and rather than pushing it with your thumb, because the thing that you'll find with these is that if you've got the stuff out on the end there and you're pushing it with your thumb, you can actually vary the reading quite a bit, like probably even by 0.1 of a mil. So what you want to do is put it in the tip and then just pinch it with your fingers, just with enough tension to hold it snug but not too much, and you'll get a reading. So that one's saying on that particular bit 171. Then what you want to do is you actually want to do it side on, because sometimes the filament is slightly ovalized. And you can see here it's now reading, well, that one's saying 17 just there, so it's about right. Now if we go a little bit further down the strand and we do the same again, now I'm getting 1.82. And so that's 1.82 on the side, 1.81. And if I do it on the vertical, I'm getting 1.75. So that section there is slightly oval. And so if you'd just done the reading in one dimension, compared to the side reading as well, you'd actually end up with different numbers. So you've got to do vertical and cross section of the filament, and you've also got to run along it a bit to get a sense of what the variation in the filament diameter might be. And then the question is like, what do you print at? And so for this, I actually was printing at about 1.8 because I found on average that was what gave me the best result. So the measuring, as I see it, provides you with a starting point, then print it, and then based on the results, and you've got to develop, I guess, a sense of what it looks like to have too much plastic going out and too little. Too much plastic, if you think about it like an Oreo biscuit, if you squish it and all the center squishes out, each layer is essentially putting down too much stuff and the print head is squishing it down and it oozes out the sides. And so you'll see that kind of filling look all the way around the layers as they build up, squished out the sides. That's what too much plastic looks like. Too little plastic is harder to identify, but what ends up happening is the layers don't bond as well and they're not as strong, and so sometimes you'll have layers that will just crack apart. It needs to be pretty excessive for that to happen, and you probably want to err a little bit on, like you really want to get it just right. You don't want to have too little and you don't want to have too much. But the first step is measuring your filament and entering it in Thing-O-Matic when you're printing. And the other thing that we found out, of course, too, was that the settings for SkinForge for the packing density, which is basically how much plastic is actually in here, was set for ABS. So ABS was 0.85, whereas PLA is somewhere between 0.97 and 1. So once we got the packing density right, measuring the filament actually made a difference. Well, the next thing I'm going to talk about is preparing the build plate for printing. Now, this was the original build plate that came with my printer, and I received a replacement from MakerBot. This one sadly was slightly warped on this corner. Actually, it was bowed up slightly, and they were good enough to provide me with a new one, which so far has actually managed to stay quite okay. One of the problems with the acrylic build plates is if you print really large parts on them, they will tend to actually bend up with the part as it contracts as you're sort of building it up. So far it actually hasn't warped that plate, but it still causes the parts to bow a bit. So I've bought some glass plates, which I'm experimenting with to see whether I can overcome those sorts of issues. It makes mating the parts together quite difficult. So here's an example of some tyres for a bicycle design. So it's a big model that I'm working on, and I need these parts to go together and to glue, and because of the bowing there's a gap. So I'm hoping that doing this on the glass plates will get rid of that problem. But anyway, before you print, you really need to prepare these build plates. So the choice is you either get some blue painter's tape and put that on the plates, or you can print directly to the acrylic. Now, of the two methods, I really like printing straight on the acrylic. It's just so easy and it works really, really well, and you get a nice finish and there's just very little stuffing around. That being said, it's a bit of a fine art the way I do it. So what I've got is I've got a little container here of olive oil. I use extra light olive oil, which has got a higher smoke temperature. And I've got a little container of methylated spirits and a box of tissues. Now, these ones are called sorbent velvet. They're really strong tissues. They don't ball up like cheap ones do. So they're kind of luxury tissues, I suppose is what they call them. And I try to reuse them quite a bit, but they've got very strong paper fibres. You can even get ones with cotton fibre that are quite good too. So in preparing the build plate, I'll put some methylated spirits. Other people can get rubbing alcohol. You can't get that in Australia, but it's what people get at chemists in the US. Isopropyl alcohol, but we have methylated spirits, works just well. And so I'll basically rub the surface of that plate down with some methylated spirits initially, just to get any sort of residue and stuff off it. This is when I first got it. I'll get another tissue and fold it up nicely. I'm a folder, not a scruncher. And I'm going to put a tiniest amount of olive oil on here. So that's probably even a wee bit too much, but that's all right. Got a bit on my hand. Okay. Then what I was doing was I'd actually rub a film of olive oil onto the build plate. So you want it to kind of end up being, if you do it in the light, you'll see it. You'll end up with this nice shiny sheen all over the edge of the build plate. Alrighty, that's kind of done it. So now it's got a sort of greasy texture to it. And you can get another tissue and just sort of polish a bit of the excess off so that it's just taking it right back. And I'll just let that sit and dry for a while, because what you want the olive oil to do is just sort of soak into the plastic a bit, and that's what it'll do. So you'll end up with this sort of very light film, like a very light oily film on there, and you just let it dry a bit. And then I'll come back with the methylated spirits again and just take the top off that. So it's kind of like you're trying to get this perfect surface where it's a bit oily, it's not too oily, and if you think of it, it's a frosted surface, so it's a little bit like the oil has gotten into the pores of the frosting, but the top layer of it doesn't have any oil on it because you've taken it off again, and you can kind of feel it. It's got a slippery surface, but it's still a bit grippy. There's probably still a little bit too much there because I haven't let it dry properly first. But anyway, and what you'll find is that the parts will lay down beautifully on that. They'll print just fine, but they'll break off really easily as well. And it's a bit of an art, like you get a feel for it. I mean, the great thing about it is if there's too much oil and it's not sticking on the first layer, pull it out, rub it down again with a bit more alcohol, have another go, but you'll get it to a point where the first layer extrudes beautifully, lays down a perfect finish, but when it comes to popping the part off, you just get that little spatula that I was showing you before, pop it under the edges and just peel the part straight off, and it works really nicely. So in terms of ease and convenience, I love printing on these build plates, but for really big parts, it's problematic because it bows a bit. So I'm using glass as an alternative for that reason. That was my warped plate. Now this is my replacement, which is still perfectly flat. And this one I've prepared with tape. Now, the tape surface, it's pretty involved. It's kind of like the same process, really. I'll show you on the other board because it doesn't have any tape on it, and that one I've already done. But basically, you're going to pull off sheets. I do the whole thing, starting at the back. On the MakerBot build plate, it's got a line pretty much on the top and the bottom. You can see them there. And what you want to do is, on the other side, you want to line up the tape edge along the line on the back there, and then just work your way forward with the 3 layers. So this is 50mm wide tape, so it does three layers to get 150mm across there. And in terms of preparing this surface, I pretty much do the same thing. I put a lot of methylated spirits, because this tape, this particular one that I bought, and this is the only one I could find in 50mm, this one's the 3M Scotch Blue, and it's called 2093EL. It's a really nice tape, but it has this kind of, I don't know, like it's printed on it, and it's got a sort of a slightly waxy surface. And I find that I've got to use the methylated spirits to take that right off in order to get things to print to it, to stick to it. Then I'll put a little bit of olive oil and I'll polish it with that, because I don't want it to stick so much that it rips the tape off when I pull the parts off. And then I actually give it a bit of a sanding with the fine grit sandpaper, sanding blocks, just to sort of score the surface a little bit. Let that oil surface dry in front of the fan for a bit, and then I'll just keep polishing it back with, or working it back with a bit more methylated spirit, so that the oil is impregnated into the tape, but it's not on the surface. And then you end up with tape that really lasts. So this has done probably 20 prints so far. So all of those dollhouse pieces that I was showing you before, I've printed on this, and there's not even a mark on it yet. So if you prepare the tape well and you use high quality tape, it really does last. And of course you can use this blue tape on glass, which is the point. So that's why I've been experimenting with printing on blue tape, because I want to use glass for the larger parts, even though my preference for printing smaller things is just to go straight on the acrylic plates, because it's just way more convenient. You know, you don't have this tape that you've got to keep reapplying and reapplying. But I'm actually getting to the point now with the blue tape where it's lasting really very well, and I'm getting good results on it. So I'm not actually at all unhappy with it, to be honest with you. But yeah, it just took a little bit of kind of figuring out, but now I've pretty much got it sorted, I think. All right, so that's the build plate prepared.